Okay, guys, so let's do this video for congruence objective 1. Now, there's a couple of notes that I really want you guys to get here. And really, like, the premise behind this whole objective is pretty simple. And the premise is this, that there are 3 different types of transformations that they call rigid transformations. And rigid means stays the same size. So the rigid transformations are the ones we've done a ton of work with already. So that's hang on, my eraser. There you go. So translations, which is just a slide. Reflections, which is, oh wait, it's not like that. Reflections, which are, you know, kind of flipping something over to the other side. Say flip, slide, and then rotations. Rotations, which are, where they go around like that. So we'll call that a spin. Sorry, the handwriting is getting bad. Okay, so those 3, if I do any of those, they make congruent images. Right, so if I translate something from one place to another, right? So if I take a triangle and I translate it somewhere, these 2, the originals, or the original and the pre-image and the image, why is that so sloppy looking? Right? But both things, those are congruent to each other. All right, same thing with a reflection or a rotation. Now, the one different one is a dilation. Dilation is not rigid, so it doesn't keep something the same size. So what a dilation does, so like let's think about a triangle here. I wonder if I can copy. Can I grab that? Yes. All right. So if I do a dilation, what that does is it actually makes it bigger. So a dilation would go from there to there. Sorry, that looks sloppy. But notice that those 2 things, they are not congruent, right? Because they're not the same size. So dilations are not, if anytime you see a dilation, that is not going to create congruent. Right? So we make congruence, and this is not congruent. So we need to know those congruent. Okay, so now let's look at the actual, I didn't do all the diagnostics, let's just look at 2 of them. Okay, so this says select all explanations that prove that triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, so let's keep this in mind, right? That A, oh my gosh, guys, why is my thing, I'm not highlighting. Won't give me color. That's okay. Oh, still won't give it to me. Right, so I need A to map onto A prime, so that's going to have to end up all the way down there, either flipping it or spinning it. Now, B is going to need to go over to B prime, and C is going to need to go over to C prime. So I need to make one triangle land perfectly on top of the other triangle to show that they're congruent. So let's see. If I translate ABC down and to the right, so let's just think about that, right? So let's take ABC. Here's A, B, C. All right. So like that. If I translate it or slide it down and to the right, well, if all I do is slide it, I don't see, sorry, I gotta get rid of these. I don't see any way that just sliding it is going to allow me to make this land on the other triangle, right? And I have to land on the other triangle for them to be to prove congruence. So I know it's not going to be that one. All right. Now you're going to see what I'm up to, but I'm going to do it anyway. So let's jump down to the third one. Reflect over BC. So BC is my line down here. Okay. Now let's think if I reflect over that. I'm going to flip that Let's see. Let's flip it vertical. So if I flip it vertical, now remember, it would flip over to the other side. I would land there. That doesn't quite work, right? Because it has to land perfectly on top of the other one. So let's think about rotate. Right here, let me see. Reflect over BC. Nope. Oh, shoot. Wait. Hang on. So reflect over. Oh, it gave me two. Guys, I almost screwed that up. So the first one is reflect over BC. Let's see where this goes. Okay. So we flip it that way. Okay. Now it wants me to reflect over the perpendicular bisector of BC. So it wants me to reflect over, if that's the perpendicular bisector, it wants me to reflect over that. Okay, so interesting. Okay, now, oh, that's a tricky diagnostic, guys, because I want to tell you this. That one's not right. Wait. Is that one right? That is the one that's right. My bad. I went into this thinking the second one was going to be right. I guess that shows you what assumptions do, right? That's definitely the right one. Let's look at this one. Why did I think that rotate around 180 around? Oh, guys, I see. Man, this is awesome. In this video, you get to witness McSparron screwing up. That's good because I've always said mistakes help you learn more than right answers. Don't worry, I'm just talking to myself. All right, so let's rotate. Let's rotate 180 degrees. So let's look at this one. Rotate 180 degrees around point C. Man, that's what's really important because here is point C. So if I rotate 180 degrees, I'm going to have to go this way and end up down here. Now let's see if I around that. No, but I'll bet you I can rotate it. Let's rotate right 90, and let's rotate right 90 again. That's going to make 180 total. So now notice, if it had rotated around a different point, it might have ended up in the right spot, but it didn't. It wanted me to rotate around point C, which would be there. That doesn't work. Man, the point is so important, okay? So because it's point C, that's not going to work. Man, you guys can see how easy it is to get tricked on this thing. I basically got tricked on it. So this is the one that you want. Reflect over BC, then reflect over the perpendicular bisector. All right, let's look at the next one. Which of the following represents two shapes that are not congruent? So first off, we know congruent means they have to be everything the same about them, right? Same angles and same side lengths. Well, let's think about what these are. I would say that this top one that's a translation. Well, a translation? That means translations are congruent. So this can't be it, because I'm looking for not congruent. Let's see, this one here, I wonder, I'll bet you either reflect this or rotate it. I'll bet you I can rotate it. Yeah, so let's do that. Let's do it. Let's rotate it 90 degrees. What? No way. That's not what I wanted. All right, so let's rotate 90. And let's rotate 90 again. Yeah, look at that, guys. So that, look, boom. If I rotate it, it lands perfectly, so it's congruent. So it can't be that. This one down here is another rotate. So if I take this and I rotate it twice, let's do that. So let's rotate 90, and then let's rotate 90 again. If I rotate twice, look at that. That's going to be congruent. Can't use it. This one. Ha! Here's the one, guys. It's kind of obvious, I know, but it's worth thinking about which one you do. Right? So, look at that. I can't just slide that. I can't just slide that. I can't just rotate that. I can't really do any of that. Now, what I could do, watch this, I could dilate it so they end up the same. But a dilation is not congruent. So this is my answer. This is the one that is not congruent because it is inflation. All right, so that's it for this objective. If you have questions, ask them. Sorry that I screwed up partway through. You can make fun of me for it.